Alright, we're on week 7, and this week we're going to be covering geometric sequences. You might want to pause the video and take notes on this, just so it's kind of clear for you. Last week we were in chapter 10-2 covering arithmetic sequences, and this was the formula you used. AN is A1 plus N minus 1 times D. We talked about arithmetic series, which was a sum. That's why there's an S here. It's a sum. The series was when you add all the numbers together in a sequence, and this is the formula that you used. You know already that all arithmetic sequences have a common difference. They show a pattern of adding and subtracting, and that they model a linear function y equals mx plus b. And you know that from when 2 weeks ago when we graphed these sequences and didn't connect the dots. This week we're in chapter 10-3 of the textbook, page 674. I encourage you to read it. This is the formula we'll be working with for a geometric sequence. AN is A1 times R to the N minus 1. Notice that in an arithmetic sequence there's a plus sign. In a geometric sequence there's a multiplication dot. So just be careful about that. Recall that all geometric sequences have a common ratio. They show a pattern of multiplication and division. They model exponential functions, which means they look like y equals a times b to the x. And we covered exponential functions a while ago. It is right before we did logarithms. So anyway, here's the formula we're using on this week's assignment. Alright, I included a handout for you to do. I said just to do the first page. So here it is. Again, this is wrong. It's 10-3, geometric sequences. Nice definition here. And here's the formula I just went over. Okay. So in our first example, it tells you to find the next two terms of the geometric sequence. You want to find the common ratio, and you do that by dividing the second term over the first term. And then, yeah, you can just multiply to continue the pattern. Writing an equation takes a little more work. Remember that this is your first term. And that'll go in the a sub 1 spot. You have to calculate the ratio by putting the second term over the first term. And that'll give you R. And then N is always the number you're trying to find. Well, usually. Alright, number 1. Find A sub N. Just using this formula here. It says N is 2. So I'm going to write A little 2 equals negative 10 times 4 to the 2 minus 1. So I plugged N here and here. I put A1 in here, and I put the common ratio R here. And now it's really important you follow the order of operations and you do these exponents first. That's negative 10 times 4 to the first. So negative 10 times 4 is negative 40. The second term in the sequence would be negative 40. Number 2. That light's so annoying. Number 2. We're given the first term. We're given the value of the common ratio. And we're given what N is. So this means we're trying to find the 8th term. A sub 8 is negative 6 times negative 1/2 to the 8 minus 1. And feel free to use a calculator here. Let's see. Negative 6 times negative 1/2 to the 7th. Negative 6 times negative 1 to the 7th over 2 to the 7th. Negative 6. Alright, so going back to number 2, our 8th term of the geometric sequence is negative 6 times negative 1 to the 7th over 2 to the 7th, which is negative 1 over 128. Negative 6 times negative 1 is a positive 6 over 128. Divide the top and bottom by 2, and we get 3 over 64. And that's your final answer for your 8th term. Number 3. So we're given the 3rd term. Be very careful. This is different than number 2. In number 2, we were provided the 1st term, little 1 here. In number 3, we're given the 3rd term. A sub 3 is 9. Our constant ratio is negative 3. That means each value is multiplied by negative 3. And we're looking for the 7th term. Wow. You could just multiply this by negative 3 7 times and get your 7th term. Well, I guess since it's the 3rd term, you would do 4 more times. Let's just look at it. We got A1, A2, A3 is 9. Here's our 4th term, our 5th term, our 6th term, and our 7th term. So if this one is 9, this must have been negative 3, and this must have been positive 1. 1 times negative 3 is negative 3. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Negative 27 times negative 3 of course is 81. 81 times negative 3, negative 243 times negative 3 is 729. I believe a sub 7 will come out to be 729. Now let's use the formula to do that exact same thing. So because if they were asking you to find like the 50th term, you would not want to multiply it. You would want to know how to use the formula. So looking at the formula, I wasn't given the 1st term. I was given everything else. I would solve for it. I would put the 9 in here. And in this case, the 3 in here. Negative 3 times negative 3 is a positive 9. And so 9 divided by 9 is a 1. So 1 is a 1. And I found that here. I shouldn't box it. So right now I'm doing the exact same thing I did up here, but I'm going the formula route. Okay? So because they didn't give us a 1, I plugged the 9 in as the outcome, the 3 in as the end value to the formula, and I simplified, and I used algebra to find A1, and A1 is 1. So now that I have A1, I can find the 7th term. Plug in what you know to find what you don't know. So this is just negative 3 to the 6. A sub 7, is 1 times 729, and A sub 7 is 729. So there, I found the same result using the formula method as I did using the multiplication method. multiplying r, I did here, using the formula I did here. Okay? If this was class, I would say use your formula every time, and I wouldn't be asking you to find like the 7th term. I would put like the 70th term, and that would prevent you from doing this. All right, number 4. So this reads, I'm trying to find the 10th term of a geometric sequence, provided that we know the 4th term is 16 and r is 2, and the constant ratio is 2. So I could make a list of all of the terms and put 16 in the 4th position and multiply by 2 to get to the 10th term. That would not be difficult. But I'm going to use the formula because knowing and understanding the formula will help you longer. So this is a little baby a. Okay. So we don't know a sub 1, so we're going to plug in this information to help us find it. I'm going to say 16 is the 1st term times 2 using this n value minus 1. 16 is a1 times 2 to the 3rd power. 16 is a1 times 8. And then I would what? Divide both sides by 8. To get 2 is a1. Alright, now we have a1. So I'm going to say our 10th term is 2 times 2 to the 10 minus 1. 2 times 2 to the 9th, which is just 2 to the 10th power, right? And there's our 10th term. Number 5. Let's, I don't want to make the video too long, so I'm going to skip to number 6 because it includes a fraction. You guys want to know the answer, though, to number 5? You guys do it yourself and try to get this answer. Number 5 answer is a sub 6, the 6th term, is negative 486. You try it yourselves. Okay. Number 6. A1 is 8, R is 2/3, and N is 5. Just want to show you how this looks with a fraction. We're looking for the nth term. 8 times 2/3. And this is one where, yeah, I do make you show all your work in class. Alrighty. What's this supposed to be, 5? I want to put a 5 here to indicate to anyone reading my problem that I am in fact looking for the 5th term. The 5th term is 8 times 2/3 to the 4th. 8 times 2 to the 4th over 3 to the 4th. 8 times 16 over 81. Dang, and 81 doesn't reduce here, so, alright. 8 times 16, let's just, what is that? So this is like 8 over 1, so it's like 8 times 16 is 128. Over 81. That's our 5th term. 128 over 81 is the 5th term. Alright, I think you're getting the hang of it. So, value. Let's move on. I'm gonna head to number 10. The directions change here. Number 10 says, write an equation for the nth term of each geometric sequence. So, let's do it. Write an equation. $500, $350, $245, ... Wow, how is this pattern going? Find R. I'll just highlight that for you, I hope. Here we go. Step 1, find R. Like how that just smears since this isn't a highlighter. I've always wondered, like, how is a highlighter different than a yellow marker? Well, a yellow marker will smear a pencil. Okay, so R, I'm going to find R by doing 350 over 500 and 245 over 350. I'm going to reduce those. So these can both be reduced by 50. If I reduce the top and bottom by 50, what is it, like 7 over 10? I get 7 over 10. And then these both reduce by like 5 minimum, right? 245 over 350. I wonder what they reduce by. They both reduce by 35, giving you 7 over 10. So that's R. R is 7/10. So let's write our equation. A to the nth power is going to be 500, because that's our first term. A sub 1 is 500, times 7/10 to the n minus 1, box it. That is your equation. Let's continue. Wait, you need me to hold? Pause. Alrighty. Let's continue. Number 11. 8. 32, 128. Step 1, find R. Well, R is clearly 4. 8 times 4 is 32. 32 times 4 is 128. But if I couldn't see that, I would do 32 over 8 and 128 over 32. Oh, 4. 4. R is 4. And we already know A1, so step 2, plug into formula. So, AN is 8, the first term, times 4 to the n minus 1. Box it. That's your equation. Okay. I'm going to skip to none, number 12. Number 12 is intriguing because it has a positive 11, a negative 24.2, and a positive 53.24. That's interesting. How can a sequence go positive, negative, positive? Well, you would never see that in the arithmetic sequences, but here, this just indicates a negative ratio, meaning your common ratio is negative. Okay, let's do this. Step 1, find R. Negative 24.2 over 11 and 53.24 over negative 24.2. already there's decimals in this problem, so I'm gonna use a calculator. Or you can do long division if you'd like, and I'm going to find a decimal answer. This one is negative 2.2. And as long as this worksheet is good, this will also be a negative 2.2. R is negative 2.2. Nailed it. Step 2, plug in. Okay, AN is a positive 11 times negative 2.2 to the n minus 1. Box it. We're done. That's number 12. How long is my video? It's pretty long, so I'm going to go ahead and stop now. And yeah, go ahead and finish 13, 14, 15, and then email me with any questions. Thank you and good night.